Okay, we'll go ahead and get started here. I'm Brandon Stevens. I'm your 4-H superintendent for the electric project, and thanks for joining tonight. And I am going to record our Zoom session tonight so everybody can go back and watch it again if you need to. And if you have any questions, don't feel like you can't ask questions. Just unmute yourself and you can talk to us. And so in the meantime, I'll just mute everybody, and then that way there's no background noise that disturbs anybody. But if you do have a question, just unmute yourself and talk to us, okay? And so tonight, our plan is I've got one meeting here scheduled that's about 40 minutes long, and then I've got a second one that I sent an email for that is another 40 minutes, and I don't think we're going to take that entire time. What I'm going to do is we're going to work about halfway through our project tonight, and then we're going to stop and take a break, and then we'll schedule another time next week to come back and work on it so that we don't burn everybody out. There's a lot of work to do in a couple steps, and I kind of go slow so that everybody has a chance to have a opportunity to work through there. And if you need to hold up your board to show me what you've done and get feedback, I can surely do that here with each of you there that has a camera that I can see you. So I'll start out here by sharing my screen here with a little presentation that I have, and we'll get started with our project here. So let me find that here for you. Okay, so this is our project that we're going to be building tonight is our series or parallel circuit board. So we won't have to decide tonight which one you're going to build, because we'll start out with your wiring techniques and it'll be the same for both boards. So tonight you don't have to make a decision, but I'll kind of give you an idea towards the end that you can make a decision and start thinking about for the next time that we meet to finish up your board, which one you want to do. Just a couple things to cover here. Some of the tools that you may need tonight that'll make it a little bit easier to work with your project is a small electronic flush cutters, something to cut the wire with, a pair of needle nose pliers that'll let you bend and manipulate the wire that we're going to be connecting up to the different terminals. We won't need this tonight, but later next time we would need a soldering iron and a some kind of tip cleaner, and then also a soldering iron and the solder. But tonight we will need wire strippers and safety glasses for you. So we have that. And if any of you need some tools, you can find those on my site. They're at eeinabox.com, and you can order any tools that you might need in case you need a soldering iron or anything else for the future projects. So today we want to make sure that you're observing safety. So we want you to be healthy and safe at the end of this workshop today. So make sure that you're always wearing your safety glasses while you're working with electrical projects, especially soldering. We won't be doing any soldering tonight, but if you're stripping wires or cutting them, those little metal pieces can fly off and hit you in the face. So we want to make sure that you're safe while doing that kind of work. The materials that you might need here, and I covered some of those here, but we're also going to need our template that is available on the website that you printed out. I hope I sent out a link for that, and I hope everybody was able to get that template printed out. And you'll need your Division I kit, and I hope that everybody was able to go to the extension office and pick up the kit for that. Also, you might need a ruler and a nail and a hammer and a little pencil. That'll help you when we're putting our parts on the board to let you mark and make little pilot holes to put your screws in. So we'll start out, it looks like I've seen a few nice boards there all painted up and finished up, and a couple of them stained and varnished and all kinds of different. This is your expression and your fun that you get to decorate your board how you ever want. And so the board size should be about 5.5 by 5.5 inches. It can be a little bit larger, but this is a good size because we do have a limited amount of wire in our kit, and so we want to make sure that your kit will fit on there and you'll have enough wire to connect everything up on your circuit. So we're going to start out here on your circuit board. So what I've done here is I've taken our template and I've cut it out. You can cut it out or you can fold it along those lines. And we're going to put it on top of your board, and you might want to tape it down so that it doesn't move. And this will give us an opportunity to use that to help locate and position our parts on top of the board. So everybody, I hope that you're able to get that little template, and you can put that on your board. So we'll start out there. Now, the very first step here is we'll take our components out of our kit that you've picked up from the extension office, and we want you to be able to put those on top of the board. And we're going to take a pencil and mark the holes. There's already some dark holes on there, but we want to make sure that your parts line up with the markings on that template. There are some kits that the switches maybe are a little bit different than what was provided before, in the same way with the battery holder. The only two parts that we do need to mark are the switch and the battery holder. The lamp sockets, we only have one hole for each of those, and so you don't have to mark those. So if everybody wants to take that opportunity to put their switch on top of that template, and make sure to use your pencil and kind of make a circle around the holes there where you're going to put the mounting screws, and make sure everything fits. We'll let you finish that up here.
I think my mom's printing out the template because we didn't get it yet.
Okay. Yeah, so I'll give you a few minutes there, and you can print out the template. If anybody needs a link to the template, I can email that out again.
Yeah, I can't seem to find the email with the template.
I can't find it either.
All right. Yeah, that was quite a while back, and so I'll resend it here. So let me work on getting that here.
So, Brandon, my wife probably is the one that gets all the emails from you, so I might have you send it to me separately.
Okay. You want to send me a chat message, and I can,
Yeah.
or if you want to send me an email, either one.
Hey, Brandon, this is Kit. We joined late. Are you, is there going to be a recording available of this, or is this just the only one?
I can hear you talking, but it's broken up. Can you say it one more time and maybe a little bit louder? I didn't hear.
Yeah, sure. Is this going to be available on a recording?
Yes, it will be. I've got several different recordings of the workshop, and this one will be recorded, and I'll put this up online also. So you can choose your version. There is one that is available on the website that is not a Zoom meeting, and it's just a video that was put together years ago. And I look much younger. And then tonight's will be recorded, and this will be available also.
All right, great, thank you.
Okay, so let me send this email out here. All right, I sent that out, so everybody should have that available there. Okay, so while everybody gets that email, and you can print that out, and then we can have you mark those parts on there and start doing it. For those that have already printed it out and marked it, I can go on to the next step here, and you can kind of catch up and look. As you see here, I've taken my pencil lead and kind of marked on there, and mine matched up on the template pretty well. So this is where the screws are going to go. Each of the holes here for the battery holder matched up in the switch. And so I hope that yours will match up pretty close. If not, at least you'll have the pencil marks to know where to put that on, and then you'll be able to make your pilot holes from those. And once we get our parts marked on the board, what I like to do is take a nail here and a hammer, and just take each one of those and then hammer the nail in a little bit, the tip, to get a pilot hole started. If you're using a piece of hardwood, you might need to go back and take a drill and drill the holes. The screws that are provided there in the kit are easy to put into a piece of pine wood, but if you've got a piece of oak or a hard piece of hardwood, it may be a little bit difficult to get that to mount the screws and mount the parts on there. So this is a way to make some pilot holes, is to take a nail and just take each one of those pencil marks and hammer in that nail a little bit so that the tip is there. When you're done hammering in the parts there, and we're going to do 8 holes. So we've got 2 on the switch, 4 on the battery holder, and 2 for the lamps. You can see all my little pilot holes here that are marked on my piece of wood that I've hammered the nail in. And that's why it helps if you tape that on top of it so it doesn't move as you're hammering and marking those locations. It will stay put, your template, and you'll be able to have those holes in the right location. I'll give everybody a chance to work through, and you've got probably a few people there I see that are putting their templates on. And while we're waiting here, does anybody want to talk about your hazard hunt that you may have done with one of your activities in your house? Did you find any electrical hazards?
We didn't do it yet.
Okay. You've still got some time before the fair. You can do a hazard hunt and look around your house to see if you find any electrical hazards.
We did have one question about the poster.
Yes.
Are we supposed to do a poster? Is there, how does that work?
That is one of the options to do a poster if you would like, but it's not required. Now, typically somebody will decide to do a poster instead of building the project. So that's an option. Now we have had people that will build the project and make a poster along with it to maybe describe their circuit and show some of pictures of you building or doing some of work on the circuit. And that is a acceptable project also.
Okay, that's a cool idea.
But typically on the first year, a lot of people just build the board and display that. But every once in a while, we will have somebody make a poster to display. Like I said, they'll maybe accompany a poster with the project, but it's not required to do a poster with the project.
Okay, and then they'll do a binder and then turn those binders in with their projects as well with all the paperwork in it?
Yes, you can, for the what I've done and what I've learned pages, you can fill those out and submit them with your project. And they don't have to be in a binder per se, but you could put it in a folder or just a protective sleeve and tape it to the project so we don't lose it. So hopefully when we check it in and do the judging there, that we can keep that all together.
Okay, so that was just, what sheet was that? That was just the what I learned and...
There's 2 sheets in the manual. One's called What I've Learned and one is called What I've Done.
Okay, not the activities though. They don't need to include those?
The activities are on that sheet. The What I've Learned sheet is about the activities.
Oh, okay. All right.
Yeah, the activity sheet asks about, I think, on the hazard hunt of what you've done, maybe about a field trip that you may have taken and learned about an electrical or something, a field trip. It doesn't even have to be electrical related, but you might take a field trip somewhere. And so those items you can put on that sheet.
Okay.
Great questions. Thanks for asking those.
Yeah.
Okay, so is everybody coming along and getting your template marked? Ready to move on to the next step? Okay, so we'll talk about our next step here, and so you can kind of push your board off to the side there. We're not going to use it for a few more minutes. And our first step that we're going to talk about is we're going to remove the insulation off of our wires so that we can make the electrical connections. So on our insulation here, let me talk about that a little bit. We're going to have 4 slides here to talk about the proper way to remove the insulation and some tips and tricks on making it a little bit easy. And then also we'll talk about what damage can occur when you're removing the insulation off the conductor and why that damage is not desirable. And then we'll give you a pro tip on how to properly use the wire strippers if you're using a pair of wire strippers to make it a little bit easier and minimize the chances of damaging the conductor, okay? So I've got a pair of wire strippers here. And as you see, there's different hole sizes. This is for the different gauges of wires that this wire stripper can strip. You may have a pair similar to this, or you may have a pair that you need to adjust and has a little screw that you can slide up and down and vary the opening of how big the opening is and what kind of sizes of wires will fit in there. So on this one here, we're going to have you squeeze the wire strippers close so the jaws will close up. And then in order to remove the insulation, it's best if you release the pressure a little bit to allow the jaws of the wire strippers to open slightly. And this will allow you to still use the wire strippers to kind of pull the insulation off of the end of the wire. You can also just, once you had cut it, you can use your fingernails and remove the insulation. But the cutting process is best if you close the jaws and then release the pressure just a little bit. If you close the jaws and then squeeze it really hard and then pull on the wire, the jaws just scrape all the way along the wire as you're removing the insulation, which makes it a little bit harder, okay? Now let's talk about how much wire or insulation we want to remove here from the conductor. we want to remove about 1/4 of an inch to 1/2 an inch in insulation. And you can see here, I've got a ruler here and it shows about 1/2 an inch of insulation removed. That may be a little bit much, and 1/4 of an inch is probably a little bit closer, but it's easier if you remove a little bit extra. You can always trim off the extra bare wire and remove it. And it's a little bit harder if you don't remove enough and then have to go back and try to restrip a little bit more. So use your judgment there. We can do 1 or 2 connections here. And on this first one, I would say maybe go for 1/2 an inch, and then that way you can trim it up a little bit if you need to and shorten it. Now, one of the parts that we don't want to do, or the damage that is possible here, is nicking the conductor. And this is what I talked about when we close the jaws of the wire strippers there. If we have the wrong size hole, or our wire strippers aren't really the best quality, sometimes the hole sizes are not properly sized for our wire. And what will happen is, you can see right here, there's a nick or a damage on the conductor. And what will happen is, after you move this wire about 3 times, it'll break off right here at this little damaged spot right here. And we don't want that. So be careful when you're removing the insulation. If you see that, what you'll want to do is you'll want to cut the end of the wire off and then re-strip the insulation, and then hopefully not get a deep gouge or a nick there when you're removing the insulation. Okay. So I'll go back to that one here, and we'll let you remove the insulation. And we want to remove it from both ends. So on that black wire, take that insulation off on both ends.
Wait, so are we doing just the black wire, the black and the white wire?
Just, let's work on just the black wire for right now.
Okay.
And ask him what gauge hole do you recommend
Uh,
using
what-
on this?
What hole do you recommend using?
What gauge?
Yes, if you have a wire stripper that's got holes in it that are gauged, it is a 22 gauge wire. So we've got a 22 gauge, or 22 AWG, or 22 GA is how the industry specifies that. So it's a 22 gauge wire. And once you remove that insulation off there, take a look real close again, look and see if you've got any damage on the conductor where you've nicked the wire. You might see a bright, shiny spot that shows up. And here's just a little bit of review. Do you remember what an insulator is? So remember that insulators do not allow electrons to flow freely through the material. And this means that the electricity will not pass or travel in an insulator. So can you name some good insulators? Anybody have some good insulators?
Glass and dry wood.
Great, yes, glass and dry wood. Any others?
Water.
Water is actually a good conductor. So water is something that allows electricity to flow. So can you think of a good insulator? Something that stops the flow of electricity.
Rubber.
Rubber, yes, okay. So on our wire, we have, actually, it's not rubber on our wire, but it's plastic. So plastic and rubber is what we line the wire with to get a good insulator. Okay, so here's some of the ones that you mentioned. We got plastic, glass, rubber, and dry wood. Okay. Now that you've got the wires stripped here, we're going to install these on your switch here. And so what we want to do is put each of the wires up through the switch here and put it by each of the screw terminals. So there's actually 2 little holes through the bottom, and you're going to put that wire through those 2 little holes. And then we want to pull them up there, and we're going to work with the ends here and make those terminals ready to put on the screws.
That through the hole.
Okay, so now on here, what we're going to do is with your needle nose pliers, we're going to bend a little hook at the end of each wire. And as you can see here, we've got our needle nose pliers just grabbing the very tip of that wire. And what we're going to do is we're going to take that needle nose pliers and we're going to roll that around the end of the pliers and pulling that wire nice and tight so that we get a tight little loop. And our goal is we're going to put that loop around that screw. So you can see how small your screws are on your switch. And we're going to just use the very tips of the needle nose pliers to make that hook. Okay, and once we get the hook bent, we're going to place the hook around the screw on the switch so that the open end of the wire wraps around in a clockwise direction. So you can see I've got a little red arrow here on that screw. The reason why we want it around a clockwise direction on any electrical connection, everything is done for a right-hand threaded screw. So when we tighten that down, as we tighten to the clockwise direction, it will actually pull that wire underneath the head of the screw and keep that underneath the screw nice and tight. If we would turn the wire around and make it the opposite direction, when we would turn that screw in the clockwise direction, it would try to push that wire out from underneath the screw, okay? So you can see I've got each of the wires and I'm going to put one around one terminal and the other around the other terminal. Now, when we're putting our wires around the terminals, here's one other thing that we need to be concerned with. We want to make sure the insulation is close to the screw head, but not underneath it. And all bare wires need to be under the screw head. So as you can see here, I've got little red arrows pointing where the insulation ends on each of these, and they're right up to the screw head, and we don't have a bunch of bare wire that's exposed beyond the electrical connection. That's important that our judges will look at that. Also, you can see that all the bare wire is underneath the screw head and there's none that's sticking out. And we want to tighten those screws down with the Phillips screwdriver. And you don't need to put solder on these because screw terminals allow us to tighten. And if we need to replace the switch at any point, we can undo the screws and remove the switch and put a new switch in and then tighten the wires back onto the terminals. This is just like your light switch in your home. You've got screw terminals on your light switch in the wall. So if you ever need to replace the light switch, you can do that. And if you're having a hard time getting those wires around the screws or underneath them really good, you might have to take your needle nose pliers and make your little hook a little bit smaller. Maybe tighten it up a little bit so that it fits around the screw a little bit closer. And then that way those wires will be underneath the screw head. How's everybody doing? Anybody need me to take a look at your wires on your screw, on your switch? I have to hold it really close to the camera there. I can't see yours. Okay, yeah, so it looks like you got the insulation up to the screw head. That looks good, and I don't see any bare wires out from around there, so that looks good, Rose. Thank you. Okay, so I think it looks like everybody's kind of moving along here, and I'll go into our next step. What we're going to do is we're going to mount our switch on your board. So you'll have to get your board back out. And we're going to work on mounting that switch onto our board. And it's very important which way we mount the switch, okay? So our judge is going to look at this. And one of the things that we want to make sure is that the knife blade of the switch here that's got the little handle on it swings in towards the center of the board, okay? So this terminal out here should be out towards the edge, and the one with the little blade on it should swing towards the center. And when you do that, we should have little cutouts on the side of the switch here. These two relief cutouts will allow the wires to bend and come in towards the center of the switch, or towards the center of the board. So when you place it down on the board, we're going to route the wires through those two little reliefs so that the wires don't get pinched. Okay. And what we're going to do is we're going to have you take your mounting screw that was in the kit. You've got 8 of those. So 2 of them are going to be used here for mounting the switch. And so you can work on putting those 2 screws in there. making sure those wires don't get pinched. And I think as you're working on that here, I will end our session, and then we'll start our second session for continuing on for the second part here tonight. So yeah, I hope everybody's got an email from me for the link again for the second one. So I hope to see everybody here back on the second one, and we'll continue on.